Welcome, everyone. Thanks for joining us for today's webinar. My name is Maaike Slot, and I'm the project manager at Fraunhofer Project Center at the University of Twente. For those of you who are not familiar with Fraunhofer Project Center, we are part of the University of Twente and partner with Fraunhofer IPT in Aachen. 5G activities are a significant part of this partnership with Fraunhofer IPT. Applications and innovations for this technology will be built and demonstrated through our Advanced Manufacturing Center. Today we are presenting 5G manufacturing. The opportunities for the European industry presented by Etienne Scholl, manager at Ericsson CU Western Europe, and Sarah Smit, research fellow from Fraunhofer IPT. Etienne Scholl is the 5G industry expert at Ericsson. He has been active since telecom for over 30 years in a wide variety of roles. The last 1.5 years, he has worked at Ericsson Center of Excellence 5G. In his current role, he's in a team that is dedicated to capture and share all learnings of the use of 5G for industrial and customers. Sarah Smit studies physics at RWTH Aachen University and has been working in the production metrology department as a research assistant with the focus on digitalization and networking of production since 2019. There she is, among other things, project manager of the 5G Sense Pro project and part of the digital infrastructure group at Fraunhofer IPT. We are very fortunate to have them take time out of their busy schedule to walk us through capabilities and opportunities that 5G can bring. Just a little housekeeping before we get started. If you have any questions during the presentation, please type them into the question box below, and we will try and address as many questions at the end of the presentation as time allows. Now, without further ado, we will give the time over to Etienne.
Dankjewel, Maaike. Thank you for giving me the opportunity to tell a little bit about 5G and the developments that Ericsson has been doing in the past decades in the mobile industry. Can you start the presentation mode? Yeah. This is the first slide, huh? Okay, thank you. What I would like to share with you is how did we decide to design 5G. We see complete evolution from the 1990s, where mobile industry came to life with the first networks in 2G. And in the beginning, everything was focused on voice. So people wanted to connect to people in an easy way. We spent over 100 years building networks that were connecting buildings to each other. So fiber cables and copper cables going from one building to another. It took more than 125 years to connect all of the world with those cables. But then people are not stuck to one building. People go from place to place and are going around. So there was a need to go mobile. And this need was really a good hit, a commercial hit back in the 1990s. In the beginning, people said, well, I don't like to go with a mobile phone over the street because I don't think that's something I'm going to use very much. But as we know today with the smartphones, everybody has a smartphone, and there are many people that even have 2 smartphones. So this was really growing fast. And then with 3G, there was a new opportunity of browsing. So not only the voice capabilities, but the browsing on the internet was something that people wanted to do, because the need for information was growing. So everybody wanted to connect to the internet. And then in 4G, as everybody knows, the slide phones came up with a lot of multimedia content, and we also wanted to see more moving pictures like videos and all kinds of applications that bring you more data on a daily basis. And that is a very good development that we have seen for the past years for communication between people, but something kept behind. In industry, we see that the people in the industry use for the communication on daily basis to each other these kind of technologies, but we were talking about the primary processes in the industry. that is still lagging behind. It is still something that didn't develop in the same pace on those kind of communication protocols. We've seen, of course, machines and machines talking to each other, but it's on one-on-one basis. And with the track of 5G, we see a stepwise change in that, because IoT, Internet of Things, is popping up, and this is being adopted very quickly. And I'll show you a little bit why. So Industry 4.0 is a topic which is used a lot in various areas of the industry. It is important to understand that this is quite an evolution as well, next to the mobile evolution that we've seen. The industry is struggling with the things that are happening in the demands from the customer. So what we saw in the first revolution of the industry is that we needed to create a mass production which was very efficient. So that took until 1950s to optimize this mass production in such a way that we could deliver a very high quality in a very high quantity towards the end customer. But then the end customer said, well, that's nice that I have a product which is equal to the product of my neighbor, but I want to customize it. I want to have my own set of tires on my car. I want to have a different type of radio. I want to have a different antenna, etc., etc. So this mass production was not good enough. It went to mass customization. And as we know of today in many industries, not only for the car industry, but many other industries as well, people just want to adapt the products to their own needs and to their own fashion, so to say, and mostly also in the very latest moment in the cycle. And for instance, if you're producing a car, it takes you a couple of weeks to produce the car. They even want to decide until the very latest moment what kind of color, what kind of radio, etc., etc. And this makes it very hard to do this mass production in such a way that is also mass customization. So needs for this production process are much more flexibility. So you need to be much more agile in your production. There's a faster time to market need, because products change very fast. You see that especially when you look at the smartphones. In the beginning, we had one smartphone, and it took 2 years for the next model came out. And now every month, new models coming out with new features, new kind of cameras, etc., etc. So this time to market is moving on in all kinds of industries. And also increasing demands on safety, security, and operational efficiency. So that's something that we see happening in many industries in parallel. And in order to cater for that, it is very important to create a wireless solution, because this wireless solution gives you much more freedom in how you adapt your processes. If you have a robot that sticks on one place because it's bolted to the ground, then you have very large limitations on what kind of sizing and what kind of activities the robot can do. But if you make this robot agile by making it flexible and moving around, then this brings your production facility in a much different status, where you can almost automatically change the production while you're making the new product. So from one product to another, you could decide to do something completely different. So here you see that cables, they're very stable, but quite inflexible. We have wireless technologies from the past, Wi-Fi, Bluetooth, Zigbee. They're quite okayish, but they have performance restrictions, mainly due to the fact that they use frequencies that are not isolated for this task, but they're shared with many other tasks. So that makes it difficult to control what is happening on the frequencies. And then we have the 5G structure, where the frequencies and the complete structure is dedicated to the tasks that it was meant for. And that makes the flexibility, together with the stability, a new paradigm for the production. And if we look in the projection of what will happen, we will see that the fixed assets will still keep growing, but in a far slower pace than the wireless applications in the factories. So this is something that will be seen back in the growth of the technologies like 5G and Wi-Fi 6. What is the difference? Well, I already said the difference is on one hand that the older technologies like Wi-Fi, Bluetooth, etc., they have a joint set of frequencies that are not controlled by anybody. It's a free road, so to say, and everybody can use it in the way they want. There are no traffic rules, so it's quite easy that you have a congestion on that road. While when you're using licensed frequencies, which are very strict to be handled, and there is control over who is doing what, then you have much more control over the capabilities of the connectivity as such. So that makes it more easy to keep the flow going in the processes. And that's the main difference of the two technology groups, so to say. We see a rising demand for, let's say, private or dedicated networks for industries. And in the beginning, we only had the macro network operator. And of course, we all know them from their use for the private telephone sets. The more and more you see applications growing in different areas like the industry for oil and gas, mining, manufacturing, warehouses, etc. But there's a difference because the area is different. Here in this large networks, we see this as a countrywide network, even cross-border network because it's roaming. And the application that you use for manufacturing, that's mainly in one building or a set of buildings where you use this network. So there's a smaller network with less users in it, but with a much higher demand for the technology needs. Because the demand is much more in the speed of the data, but also in the reliability of the data and the latency, so the delay on the lines. So why do these industries invest in cellular? Yeah, we already saw that this need for flexibility in the production is driving this for a great deal. But there's, of course, also a lot of other things, like the need for automation. We see challenges when in some industries there's a large group of older people working for a long time in the same industry. And we look at, for instance, petrochemicals, they have an issue that within a couple of years, many people go with pensions. And the younger people who work in this industry, they don't have this experience anymore from years back. And so they don't know the older type of industries. So a lot of data is being lost if we don't do something about that. So process automation is one, but also to create digital information about the process and about the industry itself, capturing that in a digital twin. That's very important because we want to reuse the knowledge of the older people who are leaving the company in a couple of years to be reused for the people coming into the company and maybe staying not so long as their former colleagues. The younger people, they stay somewhere for 4 to 5 years and they hop on to another industry or to another company. So that is something that we need to capture in the technology setup with the digital twin and with the processes around it, with the artificial intelligence and AR, VR, so that you can use this digital information also in the working processes for the people to instruct them. We need to lower the operating costs because of the worldwide global competition. So there's a lot of things that are happening in the industrial environment that drive this need for 5G and digitalization in general. Well, 5G is not one big thing. 5G is a lot of different things together, and it is a journey rather than just a big bang going from one technology to another. So when we talk about 5G, we mean that it's the same network as we use today in 4G, but with an upgrade, and not one upgrade, but multiple upgrades over multiple years. So today we can use massive IoT, so Internet of Things, for smaller devices which send only a little bit of data. We can have millions of devices in one network, but mostly that is a macro network of an operator spanning all of the country. And then we see growing needs for broadband IoT, so devices that need higher bandwidth, who send more data on a regular basis. And here in the massive IoT, we mostly talk about sensors that only send once a day or once a week, some little bit of data. But in the broadband IoT, you have devices like a drone or like AR, VR glasses that use a lot of data multiple times a day. In critical IoT, this is where the trains and other critical objects are controlled in the sense that we have control loops. They're let's say the speed of the data is not always the issue. More the reliability of the network is much more important. So redundancy is very much important. And also, if there is, let's say, in the same network in another event going on, for instance, if you're looking at a macro network with an operator, you're living close to a football stadium where thousands of people come to watch a football game and everybody's using their smartphones. Then next to the football stadium, it might be that your network is not working at the moment that the football game is on, because all those people take a lot of resources from the network. That is something you cannot have when you're using the same network for, let's say, controlling a train or controlling critical infrastructure. So in the 5G network, there's capabilities to handle that kind of specifics, that you reserve capacity, specific capacity that is always dedicated for that type of application. And then the latest, but not the least, is the industrial automation. There, it all comes together. So there's a need for high speeds, there's a need for high reliability, but there's also need for time-sensitive networking, time-sensitive in the near real-time term of the world. So that means that you want to control robots that are co-working with people, and if you do that, you need to have a robot that is aware of the people around him, and that there's no delay on the line, because if somebody sticks his arm into a machine and the machine does something and hits the arm, then this might be a large hazard. So you want the system completely robust in one sense, and also real-time controlled. And you see that in the lower axis, you have the latency over the line. You see in the massive IoT, it is not so much of an issue to have a longer latency, but in the critical and industrial automation, it is very important to have a very low latency, to make this near real-time setup possible. And 5G develops in this way, that we now have already massive IoT, broadband IoT, and critical IoT. And this end of this year, beginning next year, we have also the capabilities of industrial automation. But that's not the final stage. There will be more capabilities later on built upon this industrial automation capability. So in essence, if you look what will 5G bring, then we see a number of things. First of all, we see that the data rates go up significantly, not 10 times, but up to 100 times more than we can do with 4G. This is one thing that is needed also for the macro network, for the people who are using their smartphones, because we all create much more demand than the operator used to have in the beginning of 4G. So they need a more flexible and a more agile network that can cater for this high demand. But also in the industry, in some cases, for instance, when you're building a car, the car has up to 200 microprocessors. You need to download the software in the car within a very short time frame. So you need very high data speeds in order to do that. So this is an important step, but not the only one. Yeah. So the data volumes through the network also rise significantly. Not only the speed, but also the volumes itself go 1,000 times up. Then the latency, we were talking about the latency going down from 100 milliseconds to 1 millisecond, which is a very significant change. And then We also have the density of the network, up to 100 times more devices in the same network and in the same area of the network. So that makes it possible that you have, next to the normal users who have, let's say, the smartphones, you can also have hundreds and thousands of sensors sending information all the time towards the network. That's only possible if we reduce the cost for those devices, because nobody wants to pay $400 for a sensor that's sending a little bit of information every day. These sensors should be in the terms of, let's say, $10 or something like that. So cost needs to go down. And with the large volumes of billions of sensors, that is also possible. And if these sensors are battery driven, the battery life, which now for a smartphone is a day, battery life for a sensor should be 10 years, or something like that. And that's also something that the network is taking care of by the way of the communication types that are used in the network. And even better coverage, because now the sensors are not like a normal person who is in the living room and goes out in the street, but sensors you also use in the cellar or in the basement of an apartment building. So the coverage for those sensors need to be much better. And last but not least is also positioning. There's a lot of demand for positioning. Where is the sensor? Where are the devices that they're looking to? We want to have this accuracy within 1 meter. This takes quite some time still before we have this accuracy of centimeters, but this will come in the next coming years. And an important thing to cater for all that is that we also have the capability of slicing in the network. Slicing means that if you have a device, we're talking about, let's say, the example of the football stadium, when there's this game ongoing and all the people are talking with their smartphones, and there comes a emergency situation where the police or the ambulance needs to go in, they cannot wait until the match is over to talk to somebody else. So they need a slice of the network where this capacity is kept for them separately. And that's a very important one. I see them running out of time, so I have to speed up a little bit. So Ericsson does a lot of research in this area. We have 50 plus projects all over the world, and Fraunhofer is one of them, where we are working together with Fraunhofer in Aachen to look into the needs of the industry. And some of the industries we've been working with together is in the mining industry, where you can imagine that in a mine, there's a very specific area with a lot of hazards. We have blastings in the mine. You need to get the people out. So for the time that you have to take the people out, that the blasting will be done, and then you need to wait for the dust to settle down, and then make sure that everything is safe before the people go in. That takes a lot of time. If you can change this in the mine by building a network where the machines can be operated remotely, you save a lot of time, because you can the people will be out of the mine all of the time, so there's no hazard for the people. You only need to make sure that the machines are in the right corner when the blasting takes on, but as soon as the blasting is gone, you can bring the machines back in again. Even if it's not safe for people, the machines can go in and you have the remote control to take the things, and the production is ongoing much faster with a lot less hazard. Another example is in harbors, where we see that there's a huge demand for efficiency. We have millions and millions of containers shipped every year. And this is an example in the Rotterdam harbor, where we have automated guided vehicles that take the containers from the ships and bring them to the trucks that bring the containers inland. Here you also see that this used to be done with Wi-Fi, but due to the disturbances of the Wi-Fi, this whole setup didn't work properly because of the interference from other Wi-Fi users in the environment. So when we switched over to the private network, they had their own frequencies, and everything was working smooth, and they could have their business ongoing without any issues. So this concludes a little bit my storyline. I have some extra slides, but I want to hand over to Sarah to deep dive a little bit more into the examples that Fraunhofer is looking into in the manufacturing area. So Please, Sarah, go ahead.
Yeah, thank you very much. So thank you very much, Etienne, to this insight into 5G technology and IoT in general. I'm now going to talk about 5G, especially for the manufacturing industry. And I want to give you some examples, some concrete examples of 5G use cases in production. So I would like to catch up with the three key performance indicators of 5G that were already mentioned. There's a high data throughput, the enhanced mobile broadband, then massive machine type communication, what means we have a high density of devices, and probably the most important feature for industry, the low latency and ultra reliability feature of 5G. And with regard to a specific application, 5G can be tuned between those three KPIs, between the 3 points in the triangle here. So that means that one 5G network can be sliced to serve for different applications and to support those applications exactly with the needs they require. For example, if we want to realize a massive wireless sensor network, we would choose for a massive machine type communication, which means we have a high density of devices. But there are also applications that need a mixture between different profiles of 5G. For example, if we take process automation and monitoring, we would like to have a low latency communication, but also maybe to have a high data throughput. And therefore, we could also slice the network like this, that we have a mixture between those two performances. One second. Okay. Yes, being tunable in this different profiles, 5G can solve a lot of different applications, as I just said. So, and that's very important for the requirements of the factory of the future, because there are more and more complex processes. We want to reach a high efficiency. The wish for individualized products gets bigger, and we want to create a digital twin and a complete documentation and monitoring of every single production step. So that means we need a high interconnectivity on the shop floor. And high connectivity means that every step in the production line is not a standalone part with its own technology. It means that we create a network that is like a nervous system, interconnecting the whole shop floor and the whole factory. Since 5G can handle those different requirements, it is the perfect game player here to provide this interconnectivity. The two pictures you just saw are pictures taken from the 5G Asia, the Alliance for Connected Industries and Automation, which is a global forum to shape 5G in the industrial domain and to ensure that the needs of the automation industry are considered. And all members of this alliance have the mission to represent the interests of the automation industry and to make sure that ongoing 5G developments are also understood and transferred into industrial domain. Since Fraunhofer IPT is one member of the 5G Asia, we are also committed to this mission, and therefore we started to build up the largest industry 5G testbed in Europe at our campus here to research on 5G for industry. And this project is called 5G Industry Campus. So as I just said, it will be the largest industry 5G bed. And on this picture, you can see our campus site. Fraunhofer IPT is around in the middle. And we will have a 5G outdoor network of 1 square kilometer. And we will have 4 indoor networks in different shop floors that are fully equipped with machines and robots from our partners, WZL, FIR, and also our own shop floor at Fraunhofer IPT. And in the first part is that the network will be a non-standalone network. That means we have a 5G network running simultaneous with a 4G network. And later on, this will be a standalone network only running on 5G on the industrial spectrum of 3.7 to 3.8 gigahertz. And also we have on our side Ericsson as a partner, as network supplier. So what do we want to reach with this project? 5G has the potential to provide connectivity for a wide range of different use cases and applications in the industry, and therefore we tried to find some promising application areas and picked up 8 use cases in different areas of industry to research on them. That includes some use cases concerning sensors and 5G. For example, 5G AE sensor, acoustic emission sensor, for detection of tool breakage, or the 5G multi-sensor platform in green for workpiece monitoring. But there are also other use cases, like, for example, for logistic, 5G logistic, we try to navigate AGVs. There are combinations of 5G and blockchain to research on data economy. Of course, we also have a 5G robotics use case in it. I think that's a have-to, where we try to let mobile robots cooperate with another and try to investigate in machine-to-machine communication, in mobile machine-to-machine communication. Then we have one use case that's dealing with the remote feature, that 5G cockpit. And another use case is dealing with an optical 3D laser scanner, which we try to make wireless so that it can be integrated in robots and machines. And 5G Edge Cloud is one use case that is integrated in all of the others to make sure that the data is also analyzed in very fast and close to the applications itself. So this is one point that is always in, or mostly in all of the communication architectures included. So I picked 5 of those 8 use cases that I now want to present to you a little bit more in detail. We start with the 5G multi-sensor, which will be a sensor platform for process and condition monitoring. And the objectives in this use case is that we have modular adaptable sensor technology, which is very flexible, also flexible because it has a wireless transmission via 5G. And we want to realize a real-time monitoring with it. So this platform itself has to be real-time capable, and the transmission has to be real-time capable. And in the Edge Cloud, we also want to realize very high data analysis. All this should be then visualized and documented in a digital twin to prove it. So with this tool, we will have something that is very adaptable, flexible, can react on dynamic configuration change in the process, all this in a real-time monitoring, and uses, because of the Edge Cloud communication architecture, high-performance servers. Such an architecture with a sensor and this cloud system could look like the following. We have on the shop floor the sensor, a basic platine, and a 5G gateway. So the sensor is connected to a platine. Here, as example, it's only one sensor, but it's also possible to connect more than one sensor with this basic platine. On the basic platine, we have microcontrollers, filters, a power supply, whatever you need for the sensors. And this is connected then to the 5G gateway or 5G modem, where the data is transmitted to the 5G base station and to the 5G network. And from there, we can access the cloud platforms or the internet, whatever we need to analyze the data. Yes, that's a scalable solution. And we can use high-performance servers and shift the task wherever we have a free space and wherever we need it. The next project I want to present is also with sensors. It's the acoustic emission sensor for tool breakage detection, especially in this use case for an ongoing milling operation. And this is different from the multi-sensor platform due to the fact that it's trying to create it's creating a feedback loop to the machines. So we have a real-time processing of the sensor data that is transmitted wireless via 5G. And then in the cloud system, we have to detect the algorithmics for the tool breakage during the milling process. And then we directly give back a feedback to interrupt the process in case if there's a tool breakage detected. Going on to another project, the cockpit, so the remote area of 5G. We want to enable a remote real-time process monitoring and data acquisition. And therefore, we develop a standardized connectivity solution for cross-site communication and remote monitoring, because this becomes more and more important. If you imagine you have different production factories at different places, for example, and therefore we want to investigate in scalable data flow concepts and in processing pipelines, and we want to derive a process knowledge transfer across those sites to really fully use the power to optimize production. So we can use the information that's happening at one place for also all the others. Going on to 5G robotics, there we want to enable a wireless collaboration between mobile robotic systems. And in the first instance, we try to control 2 cooperating mobile robots that are linked by metrology and wireless communication. So they have sensor technology on board and the wireless connection via the 5G network. The last project I would like to show is concerning logistic, and there we want to show how 5G can enable an AGV-based logistic. So that's due to the fact that there's an increasing number of AGVs on the shop floors in logistics centers, and we want to implement a 5G-based cross-site autonomous logistics solution and show how 5G can be used to coordinate those systems and supply chains, for example. And here we also need the feature of localization that 5G gives us, so we can match, for example, the localization data with the data that is on board of those AGVs to coordinate it. Yes. All of these application areas could be included in one factory due to the fact that 5G can also be sliced and adapted to all those different applications. As for example, this is also planned in the Fraunhofer Project Center at University Twente. So that's an example of such a shop floor with all these different elements in it. You maybe will recognize the 5G logistics. We have a remote area for 5G cockpits. There are sensors for breakage monitoring. And we have the edge cloud computing that serves for fast data analysis and also a 5G robotics use case. So, of course, those are just some examples of how 5G can be used. And if you are curious about your very own production processes, and if you want to know if 5G would, especially for your company, an improvement, then you're welcome to take part in one of our 5G audits, for example. They have a modular approach with 5 modules. You can always choose in which you're interested in. And it starts really at the basics, where we explain 5G technology, and you will get to know our current implemented 5G demonstrators in our hall, and also can experience the network here at Campus Malaten in Aachen. There are modules that we provide for process identification in your own company, a potential analysis for the optimization potential of those 5G use cases. And if you want to have your very own 5G network for your company, we can also support you during the implementation or help you to set up a roadmap or an implementation strategy. Another possibility we offer is the ICNAP, the International Center for Network Adaptive Production, what is an international community for the development of applications and technologies in Industry 4.0. And members of the ICNAP community have the following offers. We provide trainings and seminars, studies and researches, workshops, work groups. We make hackathons and techathons for specific questions. We have a partner matching tool to connect to each other, and you will get access to test data. And each year there's also a community meeting. So either if you like to first get some experience in the planned Twente 5G project center in the Netherlands, or you would like to use our infrastructure and support, we will be grateful to welcome you and to experience the potential of 5G with you and for you. And with this, thank you very much also for the possibility through this presentation today, and don't be shy to contact me for any questions.
Yeah, thank you, Sarah. We will go ahead and take some time for questions now. Just a reminder, please, if you have a question, type it into the question box and send it to us. Our first question is for Etienne. In your presentation, you gave mostly examples of large industrial companies investing in 5G. Does it mean that 5G investments and 5G innovations and efficiency potentials are only within reach of large corporations? And how can small and medium-sized companies embrace 5G?
Well, thank you. It's a good question. Of course, now you see that a lot of R&D work is still ongoing with this kind of technology because it's quite new technology. Large companies have capabilities to do this kind of R&D, but the network itself, the 5G network, is rolled out on a nationwide basis. So the operators, they have these capabilities in their network. And even for small and medium enterprises, you can get these capabilities on a local basis when you're working with the 5G network of the operator. So not all of the capabilities can be delivered from the macro network. For instance, if you're going to use the very low latency, the time-sensitive networking technology, that needs computation very near to your own factory. But then you can have some elements of the network on a local basis in your company. So, for instance, you don't have to buy a complete own private network to have the facility. You just buy from the operator of the network that you're working with. You just buy the capability of having this low latency. Then they bring the service with the core network facilities that develop this capability. And so you can have a lot of these capabilities readily available for everybody.
Okay, thank you. Yeah, I have another question for Sarah. You have shown several use cases of 5G supporting the manufacturing environment. Will 5G support these use cases evolving over time?
Yes, in my opinion, yes, it will. Due to the fact that with the first approach of a 5G architecture, communication architecture for industry, you will have this reference architecture, and of course 5G will develop. There will once be a 6G or 7G, and you can easily just update your network and communication architecture with those new features then. So in my opinion, I think this first start with 5G now will be the basis for all the features that come up in the next years, and which can then easily involve with the system itself.
Okay, thank you. I have a question for Etienne. For factory use cases, how would you position 5G versus Wi-Fi 6, which is gaining traction in recent months? To what extent do those technologies compete or complete with each other?
Well, Wi-Fi 6 is working on the same kind of frequency setup than the current Wi-Fi 5. Wi-Fi 6 has capabilities that have a lot in common with 5G. They have also capabilities in terms of low latency and things like that. There's only one issue with that. The frequencies need to be very clean. So if you have an environment where there's not many other users around, you can control that environment, then the technologies are alike. But we mostly see it as complementary to each other. I mean, multiple companies will have their own Wi-Fi 6 solution for services that are not so critical. But as soon as the services become critical, like when you have, let's say, a hazard situation or things like that, you do not want to have the possibility that somebody else can mess up your frequencies or your network, and then you need to use the 5G. So what we will see is that a number of devices, especially Wi-Fi, is still used a lot in the office environment, but in the industrial use, it is not used so much today as well. It is used, but only in very limited numbers. And there you will see that 5G will take more of that part of the the mission critical and the business critical applications, and that the less critical applications will be done by Wi-Fi. And the 5G core network can control also a Wi-Fi network. So the traffic can be, let's say, controlled by this one controller to optimize the reuse of the complete setup in one company, which makes it much more easy to manage the total network and have a better cost, total cost of ownership for the complete entity.
Okay, thank you. Another question. Earlier you mentioned that FPC has competencies and facilitating projects in 5G. How do we find out more? I think I can answer that. Well, we're starting with new initiatives around 5G within FPC, and we are currently building partnerships and expertise around 5G, also together with IPT. We also have the AMP project and the AM Center, which will facilitate the growth and further development of these initiatives, mostly for our local industries. Following question is for Sarah. How much does the 5G infrastructure of 5G testbed cost?
Yeah, yes, that's a good question. As a company, if you want to have your own 5G web network, which is a private network, you have to split the cost, or I think split it, because you have the cost part for the use of the frequencies. At least in Germany, it's like that. In Netherlands, I think you need a network supplier for it. And you have the infrastructure costs. So for the 5G Industry Campus Europe, we have 15,000 euros for 3 years of frequency use, and around about 200 to 300 euros, 1,000 euros for the infrastructure setup.
Okay, thank you. Let's see if there's another question. I think it's a question about the AMC. Yeah, so are you going to build 5G demonstrators in AMC? Yeah, we are currently looking at developing 5G projects. So we're definitely going to look at developing also demonstrators that will be useful in the AMC once it's there. Question for Etienne. In the last year, we have seen heated debates around the security of 5G networks. How secure are 5G networks, in particular in an industrial context?
There's a lot to say about security, of course, and I might say 5G networks are very secure in the sense that it builds on the 4G security that is already the best-in-class security that we have in mobile network technologies. Every device has its own encryption in a 4G network, and this is the same in the 5G network. But on top of that, there are multiple layers added in 5G networks to add more security. But it all comes to the question, what are you going to use the network for? So like I said before, everybody can use the macro network for 5G capabilities. So if you have a small company, you can use the operator network to do many of those functionalities that you have seen, what we're talking about today. But some companies say, okay, I cannot have my data to go through an operator network because this data is so secure, or it needs to be so secure, I need to have this on my own premises. And that is the possibility when you build your own private network, then you can have, let's say, on-premise, the local breakout, as we call that. That's the setup where the data that is generated in the network will not leave your own company. It will stay in the house, and it will be managed by yourself. So that is a complete setup with all the best technologies around it, with firewalling, etc. That nobody can enter that for you to say and keeps your data secure. So if that is the case, you need to have this specific setup for that private solution. But in all other cases, the macro network itself is already very, very secure. It's the best technology that we have at the moment. So there's not one 4G network that has been hacked to date, as we know of. And it is as secure as we can make it today.
Okay, thank you. I have a question for you both. What would you say is the biggest advantage of 5G for industry, and what are the benefits for customers?
Yes, should I start? Okay. Yes, for me, as I just said, it's 5G is one technology that serves a lot of different applications. So it can be adapted for different requirements, whatever the application needs. And you have a centralized device management for all devices on your shop floor, and that's for me actually one of the biggest advantages that 5G offers. So it has a lot of features like the high data rates and high density of devices, or the low latency and reliability feature, and therefore it is just a perfect overhead as one technology for everything.
I would add to that 5G is more a concept thinking, which is quite different from other technologies before. So it is not only the technical capabilities; it's much more that what do you want to do with it. That changes, let's say, the setup for the end customer and for the industry itself. So by making everything mobile, you can give extra features like, let's say, remote monitoring of machines that you have sold. And if you today, it's normal that you sell a car. People buy a car, and you need to go to the garage when the light is blinking. But if you have a connected car and the car sends all the data to the factory can see, oh, there's something wrong, and they can adapt it while you're driving. So via the network, it is possible to change the settings of the car, or they can even plan ahead for you to go to the garage while you're planning for your business trip or your holiday trip. And then you know upfront what is needed. So it gives completely different business models. The things that you cannot do today, you can do in the future, which brings other systems also into play. Like we're all looking for sustainability, and we don't want to sell light. We don't want to sell lamps anymore. We sell only light. We don't want to sell cars anymore. We want to sell transport. So that is the change that makes the 5G possible. So it's up to your own mindset to say what is 5G capable of. It's more where are your own limitations in your fantasy that makes the limitation of the technology.
Thank you. Etienne, in 5G applied, is 5G applied differently in different parts of the world, and how does that then affect companies in Europe?
No, 5G is a global standard. So everybody who builds a 5G network needs to work according to the standard. Of course, there are little variations per product and per network, but that's only very little. So like in 4G, if you have a smartphone and you're traveling around the world, it is not necessary to buy a new phone when you're going to Australia. There used to be way back when we had 2G, then in the United States, they had a different technology. You needed to have another phone. But now, if you go around the world, it works everywhere the same way. And that is the same for 5G. So especially, it gives also opportunities to create services in Germany that you can transport literally towards another country. So if you have a factory setup with a certain machine type working in Germany in a certain process industry, you can easily transport that type of technology towards another part of the world and use it in the same way. We call that confederated network technology. So you have the same functionality in a different network in the same way. So it's working all the same everywhere.
Well, that's good there. Yeah. Sarah, if I would be considering a wireless application using industrial robots, where would be a good place to start? And would you be able to help define the applications and parameters?
Yes, of course. Fraunhofer is always open to help for finding and define the application. Concerning the place to start with, for a first test run, I would suggest that the company or whoever wants to do it tries to get in contact with places where already a 5G network is, maybe to make some tests before really setting up a whole network in their own company. So just seeing if the requirements are met and if everything is working. Yes, so I would say try to get some partners and do it together.
Okay, thank you. There's a question, are there Dutch industries connected to the AMC? I will take that question. Yes, there's certainly Dutch industries connected already, and we're looking to upscale the amount of Dutch industries connected to the AMC as well. So if you're interested, you can always contact us. Let's see, if we are interested to roll out 5G across our business, is this something you are able to help evaluate and help us with? Yes, we are. We have a good connection with Fraunhofer IPT. If additional expertise is necessary in the 5G area, we are building that as well. We're looking forward to connecting to companies that want to develop projects around 5G. Question for Sarah. Are there already any end devices available for industrial usage?
Yes, that's a good question. Actually, that's still a shortcut. There are not a lot of end devices on the market yet, only prototypes, for example. And if we talk, for example, about smartphones, there are already smartphones that have a 5G capability, but not every provider has the right chipset that is configured for the industrial frequencies. So it may be that those smartphones are configured for 5G communication frequencies, but not for the industrial ones. So, and concerning like 5G modems or modules, there's one prototype on the market right now that we use. It's an M2 module, but I think everyone is working hard on it, and there will be some more end devices in the upcoming future.
Okay, thank you. Etienne, can 5G cover also areas outside of cities as well, and well enough? Think about future increased home working and move of people out of cities?
Yeah, for sure. I mean, 5G is a general technology which will be rolled out exactly the same as 4G. And as we know, in the Netherlands, we have a quite good network coverage. So most of the people have in-house a very good 4G capability. The same applies to the 5G because it makes use of the same kind of frequencies. So we have lower bands, we have mid bands, we have high bands. The only thing is, if you want to use specific use cases where latency is required, then this is depending on the type of latency that you need. If you need a very low latency, then something extra is needed. But that is mostly only the case when you're talking about real process-driven production industries. So not for home working. And then you need a local instance that caters for that kind of capability. But in general, yes, you can use it everywhere.
Okay, thank you. Then for a last question for both of you, when do you think 5G is set to become the industry standard?
Yeah, maybe you can comment on that because we do a lot of research on that. And we think that from 2023 onwards, we see a very steep rise. We project a very steep rise in the adoption of 5G. And now we are still working a little bit in the R&D settings, and the first networks are being built for live usage. But as Sarah already told, there's a lot of homework to be done on the device type thing, because there's not so many devices yet. Chipsets are there. So chipsets have been tested and are working properly. And now the chipsets have to be installed in the devices. And that takes a little bit of time. So we're working with a complete ecosystem of vendors of these kind of devices, like AGVs and cranes and whatever. And when we look at the curve behind 2023, we see this uptake, and there's a projection that the global investment in industrial uses is getting more than the investment in the normal networks in 2035. So that's the time frame. So steep rise from 2023 till 2035. Then it's even more in industrial use than in the normal networks.
Yes, I would say that's a roughly good guess with 2023 till 35. Right now, we are starting to build applications and use cases demonstrators. We also have our own 5G network right here in Aachen, Fraunhofer IPT. So I think it will take some time to really investigate some time in those applications, and also to get in contact with industry and companies to really explain the technology behind it. And of course, it is also the question if industry is willing to try it. Right at the moment, there's a little bit shy behavior behind it, I would say, even if everyone is really hard interested in it. So I think we will see, but for sure there will be a lot of developments in the next years, and we all want to do our homework good. So I think it will be an opportunity for the next 3 to 5 years.
Okay, thank you. That sounds like we have some work to do and in the future. Unfortunately, this is all the time we have. Thank you, everyone, and a special thanks to Sarah and Etienne. We appreciate you being here. Subscribe to our channel to stay informed of upcoming webinars. And for those who are interested in understanding more, and interested to roll out 5G for your business, you can contact us by emailing fpc@utwente.nl or visit our website, amcenter.nl. Thank you, everybody.
Thank you for listening. Bye-bye.
Bye-bye.